So today I'd like to continue our work on angles, and I did promise we'd move on to some more challenging examples. Previously I've asked you simply to revise what you learned at primary school, and now I want to move on to something new. Before I do, I have what might be an easy question, what might be a really hard question. What actually is an angle? What is an angle? Now, you're incredibly familiar with angles. You've seen pictures of them hundreds of times before. But what do I even mean by an angle? I'll let that question just sink in for a minute. What do I mean by an angle? Maybe you imagine something like this. Maybe you imagine sort of a pointy thing. Maybe you think about that little bit there specifically. But what do I mean by an angle? Common wrong answers to this question are things like it's the space between two lines, or it's the gap between two lines. That's not really what an angle is. An angle is simply a measurement of turning. If you think about it, we have ways of talking about how long a line is. We have ways of measuring time or weight. But what if you want to measure an amount of turning? And the way you do that is with an angle. So it's a measurement of turning. Suppose you were standing you're standing right here. Okay, you're standing at this point here, but you're facing downwards. You're facing in this direction. If you wanted to turn to face the other direction, like so, you're now facing the other direction. You've turned through an angle. So it's a measurement of turning, and for that reason, you can turn on the spot. You know, if you stood up and you were facing one particular wall, but you still standing on the spot, you turned around and you were facing the exact opposite direction. You've just turned through 180 degrees. There was no need to draw any lines, but you've turned through an angle simply by rotating your body around. So now we know what an angle actually is. There are some special names that you probably haven't come across yet. All of the names are to do with relationships between angles, and they all happen around parallel lines. So what I've done here is I've drawn above and below the ruler to get some parallel lines. I would like you, please, to also copy this picture out. You might want to pause the video here, get the parallel lines down, and then we're going to draw as you might want to draw as we go along. So I'm going to put these little arrow symbols on there. That's telling me they're pointing in the same direction. It's a way of marking the fact that these lines are parallel. A parallel meaning even if the lines were infinitely extended, they would never meet each other because they're going off in the same direction. What I'm now going to do is take another line that will cut through the parallel lines. I don't really mind how you draw that line. You could go the other way if you like. This is not very convincing though if you make it 90 degrees. So try to avoid 90 degrees, please. But we are going to draw a line that cuts through. A line that cuts through parallel lines has a special name. It's called a transversal. A transversal. Like so. The noun is a transversal. This is a transversal. I can also use the adjective form and say this is a transverse line. Like you can have diagonal. This is a transverse line. It is a transversal. Okay. Now there are various angles in this diagram which I'm going to mark. I'll start with this one, let's say. Okay, and I'm also going to suggest that you colour code this. You don't have to use the same colours as me, but they do have to match up in the same way. Okay, so I'm starting with this one in the top right. I say top right because it's above the parallel line, but to the right of the transversal. There's one more angle like that. When I say like that, I mean it's above and to the right. Hopefully you can guess where I'm going to mark this. Well done if you said this one. This is the other one, which is above and to the right. Okay, above and to the... Now, these are both above and to the right. They're in corresponding positions, and we call them a pair of corresponding angles. Okay, these are corresponding angles. Because they're in corresponding positions. They're both above and to the right. That's not the only pair of corresponding angles in this diagram. For example, if I'd started with this one, which is below and to the right, there is another one which is below and to the right, which is here. Okay. This one here is also below and to the right. And so the green angles are the same size and they are a pair of corresponding angles. I can also see in this diagram that we have, for example, this one here, which is below and to the left. I'm going to do that one in orange, below and to the left. So below the parallel line, but to the left of the transversal. So that's another pair of corresponding angles. I could have marked this one here, which is above and to the left. Yeah, above and to the left. And because these are in corresponding positions, we call them corresponding angles. Corresponding angles are the same size. So these two red angles, whatever they may be, are the same size. These two green angles, whatever they may be, are the same size. They're not the same as the red. Okay, the green and the red are not the same size as each other, but the two greens are the same size, the two reds are the same size, the two blues are the same size, and the two oranges are the same size as each other. Okay, so they are corresponding angles. Sometimes people, when they're first learning this piece of mathematics, and are trying their best, will say something like, "Oh, Mr. Friend, I got the answer because it was a corresponding angle." And I say, "What do you mean it was a corresponding angle?" It's a good attempt at using the language correctly, but there is no such thing as a corresponding angle. It doesn't make any sense. You always have two, don't you? You need a pair of corresponding angles. I should also point out, in this diagram there are only two differently sized angles. One's acute and one's obtuse. And so, for example, it's the case that this orange angle here is the same size as this red angle down here. It would also be true to say that this green angle is the same size as this blue angle. And although they're the same size, they're not corresponding. They're in different positions, aren't they? So this green one was below and to the right, but this was above and to the left. They're not corresponding positions, they're not corresponding angles. They're the same size, but they're not corresponding angles. Okay, more words. You need another pair of parallel lines. So I'm going to draw another transversal. At this time, the ones I mark, once again, will be the same size as each other. So I'll start with actually I won't start with the same one as well, I'll start with this one. Okay, this one here, which is below and to the left, below the parallel line, but to the left of the transversal. I'm going to mark the exact like alternate version of that. So rather than being below and to the left, I'm going to do the one that's above and to the right. Exact alternate angle. And in fact, that's the correct name for it. We call these alternate angles. It's not the most bizarre name, is it? Because they're in alternate positions. This one's below and to the left, this one's above and to the right. So they're alternate angles. And once again, they are the same size. Okay, alternate angles are the same size. There is another pair of alternate angles. So if I were to take this one, for example, which is below and to the right, this one is above and to the left. That's alternate. For this particular one, for alternate angles, there's only 2 pairs of alternate angles. You don't get 4 pairs. If I point to the original picture again, you might think, oh, this is below and to the right, this is above and to the left, so surely these are alternate. That would be a good idea, but it's not true. There's only 2 pairs of alternate angles. Alternate angles always exist between the parallel lines. Okay. Okay, so we're nearly there. A couple more important names that you need to know for relationship between angles in certain positions. This time I might take this one, the one that's below and to the right. This one, which is above and to the right. What you might notice this time is these are not the same size. Okay, so this one is obtuse, clearly obtuse, bigger than 90, and this one's acute. But what may or may not be obvious to you is, although they're not the same size, there is something interesting. These two angles will add together to make 180. Okay, they will add to make 180. The name for this pair, which are well, sort of inside the C shape, I suppose, might be a way of recognizing it. These are called co-interior angles. Okay, co-interior angles. Sometimes there's another name. We use the name allied angles. You can use either, it's up to you. So allied angles is also a perfectly good word to describe the relationship between these two. And what they do, they're not the same. They add to 180 degrees. It's not the only pair of allied angles. These ones are also allied angles or co-interior angles. Okay. So they have to be on the same side of the transversal, basically. They're between the parallel lines, but on the same side as the transversal. So this one, the two red ones are both on the right. They are co-interior, add to 180. The two green ones are both on the left, and they add to 180. There's one more name that you need to know, and this is for pairs of angles which are not around parallel lines, but when you've got this sort of X shape going on, when two lines do cross over, when they're not parallel, I might choose to mark, for example, this angle here and this one here, both acute in this picture. It might be fairly obvious to you that they are the same size, and these are called opposite angles. And opposite angles are the same size. Okay, are the same size. Our American friends will call these vertical angles. In the UK, we tend to refer to them as opposite angles or vertically opposite angles. This is also a pair of vertically opposite angles here. Okay, those two are a pair of vertically opposite angles as well. Okay, so you've now drawn 4 pictures for me. In the first picture, we had that there were 4 pairs of corresponding angles. So for example, the two orange ones are in corresponding positions, both below and to the left. We could say the two green ones are in corresponding positions, both below and to the right. If they're in corresponding positions, we call them corresponding angles. A pair of corresponding angles will be the same size, okay, same number of degrees. For alternate angles, you need to switch it around. So if one angle you're talking about is below and to the left, the other one has to be above and to the right. So swap both of the languages around there. Okay, and they're called alternate angles. There's only 2 pairs of those. A pair of alternate angles are also the same size. You saw that if you're between the parallel lines, but this time on the same side of the transversal, so not like alternate angles where you're on opposite sides of the transversal, if you're on the same side of the transversal, like both on the left, then they're now not going to be the same size. You can see they're not the same size. Clearly this is acute and this one is obtuse, but they do something interesting. They both add to 180. Whereas over here, these are nothing to do with parallel lines, but they are, the 2 blue ones are the same size, they're opposite angles. The 2 red ones are the same size, they are opposite angles.